So let's look at our final sketching problem. And we've done these ones where we're looking at a plane region, but now let's look in three-dimensional space. Let's sketch some vectors in the velocity field. I'll call it V of x, y, z spits out 16 minus x squared minus y squared k, where x squared plus y squared is less than or equal to 16. So if you're thinking about, look at your equation for v, z is not involved here. And so really what you can do is you can think of v as describes the velocity of a liquid flowing through a tube, a circular tube of radius 4. So here's my three-dimensional system. And you're gonna plug in some points. So let's start with, I plug in the origin. I get 16k. So at the origin, I get a vector going straight up the z-axis, a length of 16. And so we're going to stick with focusing on our xy plane. But now let's look at a circle of radius 1 now. So you would get 15k if I plug in 1, 0, 0. So I still have a vector pointing upwards, but it's not straight up, but it's not quite as long. It's almost as long. Let's see if I can draw it straight up. Okay, there you go. And you can plug in other points on the circle, right? V, if I take 0, 1, you'll still get 15k. You'll always get a vector of length 15. You always get 15k if you take any point on the unit circle. So now let's go out to a circle of radius 2. You'd get 12k. So if I expand my circle now to a circle of radius 2, again, I'm only in the xy plane. My vector's still going to go vertically up, but it's not going to go as far. It's going to go a length of 12. If I take a point on a circle of radius 3, you'll get 7k. So again, it's going straight up, but not quite as far, as high. And then finally, at the edge of the tube, a circle of radius 4, here's 4, if I look at a circle of radius 4 here, you get 0k. So there are no vectors on the edge of on the outside of the tube because there's no liquid flowing there. So at this vector field, all my vectors point vertically up the z-axis.